Before we get too far into this proof, we want to think about what we're trying to prove. So we are trying to prove that those two triangles are congruent, right? And we just learned a whole bunch of different ways to prove that triangles are congruent. We have side-side angle. Nobody's going to yell at me? I said we have side-side angle. No, that's a donkey. Can't do that. So we have side, side, side. We have angle, side, angle. We have side, angle, side. A whole bunch of different things. The only thing we cannot have are donkeys and AAA, right? AAA and donkeys. Okay. All right. So let's think about this. So we need to build our proof to end up at either like side, angle, side or something like that. Then we can say the triangles are congruent by side, angle, side, or whatever we end up saying. Okay. So if the givens are not displayed on your picture, go ahead and display them. But in our case, BD perpendicular to AC, it is displayed there with the right angle sign. AD congruent to CD is also displayed on the picture with the congruency markers. Okay. So does the given give us any information about sides or angles? Yeah.
It gives us a side.
It does give us a side. So I am going to tell you, it's going to be in your best interest when you are building a proof to put yourself little notes out here. So we're going to call this S. Because now we know we have said a side is congruent. Okay? When we get to an angle or another side or another angle, then we will write those pieces there until we have 3, and then we'll determine if those 3 can give us congruence or not. Okay? All right, so remember, our goal with trying to prove stuff is to squeeze as much out of the given as we can. So obviously AD congruent to CD gives us a side. That's about all we can squeeze out of that. What can we squeeze out of being perpendicular? BD being perpendicular to AC. Yep. We could say BD is congruent to BD. So that's not necessarily from the given. So I'm going to do that in a minute. Okay? But that's good that you recognize that. So we'll get to that one in a minute. But let's try to squeeze as much out of our... Not to say you could... If you were doing this proof on your own, you could totally do that now if you want to. Okay? Not to say that there is a particular order, but I just want to squeeze as much as we can out of the given first. So we don't lose sight of that. We do have a right angle. What angles are right angles? Because remember, a perpendicular line generally creates 2 or 4 right angles, depending on... Good. ADB and CDB. So that's what we're going to say second. So we're going to say second, we're going to say angle ADB and angle CDB are right angles. Okay, and then that is, how did we know the right angles? How do we know the right angles? Yeah, they're perpendicular. That's how we knew they were right angles, right? So we're going to call this the definition of perpendicular. I literally hate this stylus with everything inside of me. I don't. It's the only one I have.
Use your finger.
Ugh.
Too good for that.
Yeah, I am too good for that. All right. That does not quite yet tell us that they are congruent, though. But what is true about every right angle? What is true about every right angle? It does measure 90 degrees. We don't need to go that route because we don't need measurements. But what is true about every... I guess let me ask it this way. What is true about every set of right angles? They're congruent, right? So let's say 3. We know that angle ADB is congruent to angle CDB. And then we're going to call that the right angles congruence theorem. Okay, the right angles congruence theorem, because we know that all right angles are congruent. Okay? So ADB is congruent to CDB. That is now angle, right? So I'm going to put my little note over here to the side. Angle. So we have side angle Now what'd you say, Haley?
BD is congruent to BD.
Good. BD is congruent to BD, and we know that. What's the reasoning for that one? Reflexive property. So we can say segment BD is congruent to segment BD. And then we say that is reflexive. Okay? So that is our third piece. So make sure, so let's go back up here to our picture. Let's label what we know. So we already know A, D, and DC. We figured out that these are congruent angles. And we figured out that BD is congruent to BD. So we have, and remember you got to follow it in order, side, angle, side. Is side, angle, side good? It is good. So we can go ahead and say the triangles are congruent now. Okay, so now we're going to say lastly, number 5, that triangle ABD is congruent to triangle CBD. And number 5, we're going to say, not angle first, side, angle, side. What'd you say? Can we never do that again? You know what? I think we should do it about 5 more times. And then you know what? I think we should do about 10 more on prep. And then you know what? I think we should like take a quiz and do a bunch more, and then a test and do a bunch more. It'd be great. All right. I want to change number 2 up a little bit. Okay? I want to change number 2 up a little bit. Because all of the problems, I didn't realize this before I attached this note sheet. But all of these have you solving for, or trying to prove that triangles are congruent, and not every problem is that way, okay? I'm going to add one more theorem into your repertoire here, okay? So instead of saying the triangles are congruent, I want to take it one step further. So mark out your proof part, and we're going to make our own proof part. We're going to say segment JK is congruent to segment ML. Okay, I'm going to add one more theorem into your repertoire here. Okay, so let's just do it over here where we have some available space. Okay, so over here where we have some available space, let's talk about one more theorem. I didn't want to do a whole note sheet just on this one theorem, so I just kind of added it in here. Okay, it is CPCTC. CPCTC. Okay, it stands for, I'm not going to write this down, but if you really want to write this down, you knock yourself out, okay? So CPCTC stands for corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So what that means is, so like say I have these two triangles. And I know side, angle, side. If I know side, angle, side of these two triangles, we can say these triangles are congruent, right? And then if we can say these triangles are congruent, then I know that all corresponding parts of those two triangles are now congruent. So say this was the side in question. Okay, say that was the side in question, the side that I just colored in red. If I got side, angle, side from totally different pieces and am able to say that those two triangles are congruent, then I can say, hey, I know those two red sides are congruent because of CPCTC, because, corresponding parts of congruent triangles are congruent. Okay? So anytime you are proving congruence of triangles, you use side, angle, side, anything like that. Anytime you are trying to prove that corresponding parts are congruent, that's when you have to use CPCTC. It's just one extra step on the end. Okay? Yes, sir.
You say it again.
Yes, corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Okay? All right, so now let's look at the problem that I just had you change just a little bit. Okay? So you can see that that is going to apply here because we're not just trying to prove that the triangles are congruent. We're trying to prove that a certain side of them are congruent. Okay? So before we can prove that those sides are congruent, those segments are congruent, we have to prove that the triangles are congruent. So let's do that first. Okay, so as of right now, we have the given, so let's write that down. All right, so number one, we have Jn is congruent to Mn, and we have Nk is congruent to Nl. And that is my given. Okay, so what does that give us? You may want to, on a problem like this, go through and say, okay, so JK is one of the sides of this triangle, right? ML is one of the sides of this triangle, so I'm trying to prove those two triangles are congruent, right? So what does the given give us? Two sides, right? So two sides. So let's put our little note out here. This is side, comma, side. So that gives us two sides. So if we have two sides, what are our options? Because remember, we got to be careful with donkeys. If we have two sides already, what are our options? Yep.
Side, side, side.
Good. We can do side, side, side. That is probably not what we're going to do here, right? Because we're trying to prove that the third side is congruent. So that's probably a hint. That is an option, right? But that's probably a hint that we're not using that here, right? So if we have two sides already and we can't use side, 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 what is our only option left? Yep.
Side, angle, side.
Side, angle, side. Remember, the angle has to be between them. So let's check out the angles between them. Okay? So if we go up here to our picture, the angles between them would be this one right here and this one right here. Right? Everybody have an idea? Now we could say those are congruent? Yep.
The vertical angle.
They are vertical angles. Okay, remember all vertical angles are congruent, right? So we can say that these two things right here are congruent. So let's go ahead and do that in our proof. So number two, we're going to say angle JNK is congruent to angle MNL. And we're going to call that vertical angles congruence theorem. Okay, we knew they were congruent because they're vertical angles, so that's called the vertical angles congruence theorem. So there will be times, guys, where you got to remember those parallel line things like alternate interior, alternate exterior, linear pair, vertical angles, all those different things. Okay, so you got to kind of keep those in mind. Proofs just kind of build on each other. Okay, so now we have side, angle, side. So now what can we do? Now that we have side, angle, side, we can do triangles, right? So let's do the triangles. So third, I'm going to say the triangles are congruent. So that would be triangle JNK is congruent to triangle MNL. And how did we know that the triangles were congruent? What was it?
Side, angle, side.
Yep, side, angle, side. Okay, so now that we know the triangles are congruent, now what can we say?
CPCTC.
Yeah, so that's going to be our reasoning is CPCTC. But what can we say as our statement? Yep, JK is congruent to ML, right? Because those are corresponding parts of congruent triangles now, okay? So fourth, we're going to say JK is congruent to ML as segment. Segment JK is congruent to segment ML. And then 4, we're going to say CPCTC. Corresponding parts of congruent triangles are congruent. Okay? So you can see on almost all of these triangle proofs, you have to prove that triangles are congruent first, right? So on almost all of these triangle proofs, you're going to have to prove that triangles are congruent first. Okay? If that's the proof part, you're done. If the proof part is not about the triangles and it's about a piece of the triangles, then you got to go one step further and say your CPCTC for whatever part is in question. Okay? You guys have questions? Okay, so I want you guys to do 3 and 4 together with your group. So 3 on this side, 4 on the back side. I want to prep you a little bit on 3. Okay? So just as you are looking through the given on number 3, what word do you see that's different than what we saw in the first 2? Bisects. And what does bisects mean? Cuts it in half. Exactly. Right? Okay. So you guys go ahead and do 3 and 4 together with your groups. Go ahead. Okay. So on number 1, it tells me that AC bisects those 2 big angles. Right? So if I know that AC bisects the angles, that means it cuts it directly in half. Meaning I can tell the angle BAC is congruent to DAC. I can also conclude that BCA, is congruent to DCA. Both of those would be definition of bisector. So when it says it bisects, it cuts it in half. So that means the 2 pieces are congruent, right? So I have angle. I got to get a side in between them. So the side in between them we're going to find with reflexive because it's the side that they share. So AC is congruent to AC by reflexive. And then from there I have angle, side, angle. Right? Okay, any questions on 3? Okay, pretty simple 3 steps. The first one is the given. And the given tells you B is the midpoint. And then it also gives you a side, right? AB and BE. Okay, or ED, no. AB, oh, I wrote that down wrong. That's why I'm confused. This was EB, not ED. Sorry. Okay. All right. It also tells us an important step, so you guys need to realize this. If you are ever going to use hypotenuse leg, remember, you have to say that they are right triangles, okay? So it tells us that angle C and angle D are right, telling us that those are right triangles, okay? So once we say that we know that, or once we know that we have the right angle in there, then we know we can use hypotenuse leg. So it gave us the hypotenuse in the given. We can determine that the bottom legs are congruent by the definition of midpoint, and then we can use hypotenuse leg to say that those are congruent. What if I needed to take my proof one step further and prove that AC is congruent to ED? Yep, that's when I would use my CPCTC, right? Because AC and ED are corresponding parts of congruent triangles. Okay? Can I get a comfort level on how you're feeling right now on these triangle proofs? 3, 2, 1, 0. 3 is good. 2 and you're flipping me off. Just kidding. You tried to do it. You tried to do a 2.5, and it was not pretty. Okay. All right. So let's practice. Okay.